Finally, let's tackle another issue with our implementation. You must have noticed that our application returns errors in a very specific format. This format is the default one in ASP.NET APIs. It is part of a standard, it even shows which one specifically. But there are issues with that standard. First, this type field is repeated over all responses, and thus unnecessarily increases the payload. The title is also pretty much useless. The status is already handled by the HTTP code. We don't need to duplicate it in the response body. Trace ID is fine, but we currently don't use any tracing solutions, and so this trace ID is generated randomly and thus also of no help to us. What we want to do is keep the errors, either all of them or just one, and also add an error message along the error code. Also, our response format is different for successful requests, which introduces additional complications for the clients trying to deserialize the answers from the server. To fix all that, we need to introduce our own output format. Let's see how we can do that. To have a unified format for all our responses, we need to define that format explicitly. For that, I'm creating a class called envelope. This class will contain a result, which is going to be one of our response data contracts. Notice that I'm defining this property as an object. We don't need to make it generic because the only purpose of this envelope class is to be serialized into JSON. Then we will have an error code, an error message, the field containing the error, and the time this envelope was generated. In a microservices architecture, we would also have a trace ID here, but we don't need it in our particular case. Defining a private constructor and some static helper methods so that we don't have to use the constructor on our own. We will be creating envelope instances through these OK and error factor methods. Notice that there is no status field in the envelope. The status is implicitly derived from the presence of the error code field. The best way to use the envelope in controllers is to define corresponding methods in the controller base class. The first method will be the OK method. Here we will instantiate an envelope and pass it to the OK method from the base class. The second method is going to be error. It will return bad result with another envelope instance. Note once again that the envelope class doesn't relay information about the HTTP code, such as whether the response is 200 or 400. This is controlled by these methods in the base controller class. This is fine if we only have two HTTP codes, 200 and 400, but it is not good if we want to use other HTTP status codes, for example 201 or 404. Not all of those HTTP status codes have corresponding methods in the base ASP.NET controller. And so if we want to be more agile with regards to HTTP statuses, we need to introduce our own action result, which I'm calling envelope result. This result will contain an envelope instance along with the HTTP status. Adding a constructor. Its implementation is rather simple. It just creates a generic object result and specifies the HTTP status manually on that result. Now we can rewrite our implementation using the envelope result. Removing this. Same for the notFound method, except that I'm passing in notFound HTTP status, and the same for the 400 response. We could also introduce a method that converts result instances into an envelope result. It's unlikely that we will use it in our sample project, but it may be useful in some of your scenarios. Now, if we go to the student controller and navigate to the definition of the OK method, you can see that it uses the OK method we just defined. Let's run the application and try this out. Sending the correct request. And here's the structure of our envelope with all the fields we defined earlier. So once again, envelope is a universal format that either returns a result or an error. Let's try to send an invalid email. And you can see that this time ASP.NET uses the old output format. The reason why is because we're not using our explicit error method that we just defined. The error is returned automatically, even before the execution enters the controller method. And for those errors, ASP.NET uses the default formatting. To fix this, we need to interject into the process of forming the automatic responses by configuring API behavior options. Here, we'll be defining our own model state response factory. Let me adjust the formatting. Good. Model state validator is going to be a class with just one method. This method will look into the model state and take the first error. Note, by the way, that this error will always be here, otherwise ASP.NET wouldn't invoke this method. After that, we will need to somehow get the error itself in order to instantiate an envelope with that error. Currently, our custom validators return an error code. In order to show the full error, we also need to somehow provide an error message along with the code. Unfortunately, ASP.NET's model state only works with strings. It doesn't have an option to pass a custom error object. And so to overcome this, we need to serialize our errors when we do validation, and then deserialize them back to objects when we render those errors into envelope instances. We'll use a separator to distinguish between the error code and the error message. The serialization logic itself is simple. Just put the code and the message separated by the separator into a string. The deserialization logic is also quite simple, just do the opposite conversion. Now we can treat the error message from the model state as a serialized error, deserializing it into an object, creating an envelope and an envelope result, and returning that result. This factory will instruct ASP.NET to render automatic responses using our universal format. This was the receiving side. We also need to fix the sending side. Here you can see we are recording the error code right now. We need to serialize it instead, so that the model state error factory can properly deserialize this error. Same for the mustBeValueObject extension method. And let's run the application again. Sending an incorrect email address. And here you can see the error is now rendered using our envelope data structure. Alright, that was our custom validator that works on top of entities and value objects. Let's now try to send an incorrect name, for which we didn't use any custom validators. And you can see the problem here. By default, Fluent Validation populates the model state with regular error messages, such as the one you can see here. And these error messages don't comply with the format our model state factory expects. This particular error comes from this extension method, which makes sense because this is the default extension method used by Fluent Validation, and it doesn't know anything about the error class we just introduced. We can fix that by creating our own extension methods that will extend the default ones. So let's do that. I'm adding a notEmpty extension method that has the same signature as the default one. Inside of it, we're calling the default extension method and passing a custom error message, where we're serializing the value is required error. Now our validators will use this extension method instead of the default one. And let's do the same for the length extension method. Calling the default validator and passing a custom error. Notice that we're using the serialize method everywhere. We could avoid that by introducing an overload for this method that would take an error instead of a string and do the serialization internally. Same for this addFailure method. We could also add an overload such that we don't have to serialize our errors manually. I'll leave this as an exercise. Let's run the application and send the same request. And you can see the introduction of the custom extensions fixed the issue. The errors are now deserialized correctly. This way, we can override any Fluent Validation extension method such that it returns our custom error messages instead of the default ones. Here, for example, you can see the extension method that we introduced in a previous module. It checks the collection size. Now that we've moved away from using strings to represent errors, we need to refactor this method too. Let's introduce two new errors. I'm calling the first one collection is too small. Notice that this time I'm passing in some additional information that may be useful for debugging. Using this error here. The second error is the collection is too large. And also using it here instead of the string. Once again, it's a good idea to introduce an overload for the add failure method that would accept an error instance, so that we don't have to serialize that instance manually all the time. Alright, this way we have tackled validation, or 400 errors. The cause of those errors is the user input. But what about the internal server, or 500 errors? Those take place when there is an unhandled exception in your application, and those also need to have the same structure as all other application output. Let's see how it's rendered now. Let's put an exception here and run the application. Sending a request. The debugger shows the thrown exception, and this is how that exception shows up to the client. We need to fix this as well. We already have a global exception handler that processes all unhandled exceptions. We need to adjust it so that it uses our explicit errors. Adding a new error for unhandled exceptions and instantiating it here. Note how we return the full error message only in the development environment. This is useful to not leak any implementation details to potential attackers in production. Instantiating an envelope, serializing it, and writing to the response stream. Let's try this out. Sending the request, the exception, and you can see the exception details are now displayed using our envelope structure. Alright, let's recap everything we did.